Hi everyone, it's Mrs. Summer here to talk about calculating the pH of strong acids and bases. This is lesson 803. So the goals of this lesson is that you will be able to describe the difference between strong and weak acids and bases and calculate the pH and pOH of strong acids and bases using the following equations. 14 is equal to pH plus pOH. pH is the negative log of the hydronium ion concentration. The pOH is the negative log of the hydroxide ion concentration. To determine the hydroxide ion concentration from pH, you use 10 to the negative pH, and to determine the pOH from the hydroxide ion concentration, you use 10 to the negative pOH. So if you recall, the pH scale 0 to 7 is acidic and 7 to 14 is basic. So the pH scale increases by factors of 10. Each whole pH value below 7 is 10 times more acidic than the next value up the scale. In other words, there will be 10 times the amount of H plus ions or hydronium ions in pH of 4 than there will be in a pH of 5. So examples of acids, alkalis, and the pH scale. So if we look at if something has a pH of 14, it has a hydrogen ion concentration of 1 times 10 to the negative 14th. And if we're talking about H plus concentration, it can also be referred to as the H3O plus. So like hydrogen ion or hydronium ion, they mean the same thing. So a pH of 14 would be a drain cleaner. pH of 13 would be 1 times 10 to the negative 13th, which would be bleach. And so you can look at all of these different values. So this would be alkaline, which is another word for saying basic. And then if we look at acidic, if we look at battery acid has a pH of 0, which means its H plus concentration or hydronium ion concentration is 1. And that'd be battery acid. So you can look up urine has a typical pH of about 6. And then pure water has a pH which is neutral, which is 7. To represent concentration, we use these brackets to represent it. So pH is the measurement of the concentration of H3O plus ions, and H3O plus is read as the concentration of the hydronium ions. pOH is the measure of the OH ions. Hydroxide, or the brackets with OH and minus, is read as the concentration of hydroxide ions. So if we look at these pictures here, we see that when something is basic, it has, when something is acidic, it has way more H pluses than it does OH minuses. When it's a neutral pH, they have equal amounts. And when it is basic, it has way more hydroxide ions than H plus ions. So strong versus weak acids and bases. So strong acids and bases, what they do is fully dissociate. That means when they are split up into water, we have H plus and Cl minus, and there's no, what we'd like to say, so there is no HCl, like the whole compound in the water. It's just H plus ions and Cl ions floating around. When we say it's partially a weak acid or base, it means it partially dissociates. So we have HF breaks up into H plus and F minus, but if you can see, we have some F particle like molecules in there, some fluorines, and we have some H plus hydrogen ions present. Please don't confuse it being called a weak acid base for the strength, like, so the dangerousness, like how dangerous the acid or base is. So hydrofluoric acid is an extremely dangerous compound, extremely dangerous acid. However, it's a weak acid because it only partially dissociates into water. So if you recall, since strong acids and bases fully dissociate, we can use the following equations to calculate the pH or the pOH. So it's a strong acid. We can use these for strong acids and bases, not weak acids and bases. So 14 equals pH plus pOH. pH is the negative log of the hydronium ion concentration. pOH is the negative log of the hydroxide ion concentration. The concentration of the hydronium ion is 10 to the negative pH, and the concentration of the hydroxide ion is 10 to the negative pH. Like I said, weak acids and weak bases use different equations since they are an equilibrium, which will balance out with some bonded and disassociated. So we will not cover these in this course. We will talk about them at length in AP chemistry. So here's the relationships between these equations. If you are given the hydronium ion concentration, you can calculate the pH by using the negative log of the hydronium ion concentration, and that gives you the pH. If you're given the pH, you can find the hydronium ion concentration by taking 10 to the negative pH in your calculator. And then to convert between pH and pOH, you must use this equation. 14 equals pH plus pOH. Then, if you are given the hydroxide ion concentration, you can calculate the pOH by doing the negative log of that hydroxide ion concentration. If you're given the pOH, you can use 10 to the negative pOH to find the concentration of the hydroxide ion. Please write this table in your notes. Okay, it will be very useful for your mastery checks. How do we do this on our calculator? You use the log button, which is right there, and then for scientific notation, you need to use the second comma like we used in. So we're going to do one together. So we are given the hydronium ion concentration, and we need to calculate the pH. So in order to do that, we're going to do, in our calculator, negative log of 1 point, let me change that number, that bracket, 1.22 times 10 to the negative fifth in our calculator. And when we get that, we get our answer as 4.91 as our pH. pH does not have a unit, okay? You just leave it as the pH of 4.91, okay? So then we want to note the hydronium ion or hydroxide ion concentration and the pOH. So the pOH is going to be, change colors. The pOH is going to be, 14 minus the pH. So pOH is equal to 14 minus 4.91, which is 14 minus 4.91, and we get our pOH of 9.09. Okay, and then our hydroxide ion concentration, we can use (10 to the negative 9.09), which give us a value of 8.13 times 10 to the negative 10th as our hydroxide ion concentration, which goes 8.13 times 10 to the negative 10th. And that does have a unit of concentration, which would be molar. Okay? So this should also have a unit of molar. And it's an acid. It's an acid because the pH is lower than 7. Okay, here's another example. So we're given the pOH this time. And so for the pOH, we're going to first calculate, so we can calculate the pH. So pH is equal to 14 minus the pOH. pH is equal to 14 minus 2.56, which is equal to 11.44. Okay, now if we are going to calculate the hydronium ion concentration, we're going to do, so the concentration of H3O plus is equal to 10 to the negative pH. So that's going to equal 10 to the negative 11.44. So the answer there is 3.63 times 10 to the negative 12th. To calculate the hydroxide ion concentration, we do 10 to the negative 2.56, and we get our answer as 0.0028 molar concentration. And now you determine whether this is an acid or a base. So this would be a base because the pH is greater than 7. Now you try, determine the hydronium ion concentration, the hydroxide ion concentration, and the pOH when given a pH of 9.46, and then state whether it's an acid or a base. Okay, so the hydronium ion concentration would be 3.47 times 10 to the negative 10th molar. The pH was given. The hydroxide ion concentration was 2.88 times 10 to the negative 5th molar. The pOH was 4.54, and it's a base because the pH is greater than 7.